Hello everyone. Our today's topic for the A-level chemistry is chlorides of period 3 elements. Chlorides of period 3 elements. This is our third period and we are going to discuss their chlorides. As we know that the metallic character from left to right and the period decreases. So all these metals reacts with chlorine, sodium, magnesium and aluminium. All these three reacts vigorously with chlorine, show vigorous reaction with chlorine producing the respective chlorides. For example, sodium metal react with chlorine producing NaCl. Magnesium react with chlorine producing magnesium chloride, and aluminium react with chlorine producing aluminium chloride. In all these three chlorides of sodium, magnesium and aluminium, their oxidation state remains the same, +1, +2 and +3. Now, silicon show slow reaction with chlorine. Silicon show very slow reaction with chlorine and it produces silicon chloride, silicon 4 chloride, SiCl4, very slowly reacting with chlorine. Now, the phosphorus react with chlorine vigorously and it can produce two types of the chloride, phosphorus 3 chloride and phosphorus 5 chloride, depending upon the concentration of the chlorine available for the reaction. Similarly, sulfur react with chlorine producing sulfur monochloride. This is also a compound, but it is not very much a stable one. These are the chlorides. If we look at the structure, at the molecular structure, sodium, magnesium and aluminium chloride, they are the ionic chloride considered. Normally aluminium chloride, AlCl3, it exists just like this, but normally aluminium, it also exists in the form of Al2Cl6 as a dimer of aluminium chloride. This chloride is formed by the bridge bonding. For example, if we show this is a chlorine, aluminium, this is another aluminium atom. We know that this also have 3 electrons in its last shell, and this also show a 3 electron in its last shell. Now, if there are chlorine Cl, it means that they have 7 electrons in their last shell. 7 electrons are shown. These are covalent bond formed with aluminium. And similarly, also chlorine are present in this form with the all electron forming covalent bond with the aluminium atom. Now all these are satisfied, making a covalent bond. But what happens? Both of the chlorine in the form of AlCl3, the last shell of aluminium is electron pair deficient, so it can act as an acer. That's why it happens that this chlorine can donate a pair of electron to this aluminium, and this chlorine can donate a pair of electron to this aluminium atom, so that their last shell should be completed. In this manner, 2 units of AlCl3 combine together and exist as a dimer, which is called Al2Cl6, and this happens in the hydrated form mostly. Now, when aluminium dimer is added into water, then 5 water molecules remains attached with the positively charged 3 positively charged aluminium ion, and one of the water molecule is decomposed, in which hydroxide ion form a coordinate covalent bond with the aluminium while producing H positive ion. Due to this H positive ion, the solution of aluminium chloride, solution of aluminium chloride becomes acidic in nature due to the production of H positive ion. It means that from left right in the period, the nature of the chloride, starting from neutral one, the acidic character increases. This pH of sodium chloride will be 7, but the pH of the magnesium chloride will less than 7, show very mild acidic character. And similarly, the aluminium chloride show marked acidic character. The silicon chloride shows significant acidic character. Why? Because due to the hydrolysis of silicon chloride with what molecule? It produces silicon dioxide, white precipitate, and hydrochloric acid gas is produced. As this is a very strong acidic gas, that's why whole of the solution due to the production of this acidic gas becomes strongly acidic. Now, similarly, these two chlorides of phosphorus 3 chloride or phosphorus 5 chloride, if we react phosphorus 5 chloride, it can also be hydrolyzed, reacts with water, producing phosphoric acid and hydrochloric acid gas. It means that both of these are produced, the substances are acidic in nature. That's why the aqueous solution of PCl5 will become very strongly acidic in nature. Similarly, the sulfur monochloride also react with water, decompose and immediately produce hydrochloric acid and sulfur dioxide, due to which it also produces a very strong acidic solution. So in this manner, this is the overall character of the chlorides from left to right. All the melting point and boiling point of these chlorides also from sodium chloride it increases, and then from silicon chloride it, due to the formation of the small molecular structure, melting point and boiling point decreases significantly. Now, one thing which is a necessity to explain, that are, for example, only magnesium is the metal which show a little bit different behavior. If we treat magnesium with cold water, then it will produce magnesium hydroxide as a result of a very slow reaction along with the hydrogen gas. But if we treat magnesium with steam, if it is a gaseous state, if water is present in gaseous state, then it will produce magnesium oxide and hydrogen gas. Now, it means that at a higher temperature, magnesium becomes strong reducing agent that reduces water, immediately removing oxygen from it and liberating hydrogen gas. This is also a very important feature of this. Next is the oxides of alkali metals and alkaline earth metals. They are strongly basic. Why? Because in case of Na2O, say, it will be ionized, producing 2 Na positive ion plus oxide ion. Now, this oxide ion produced immediately react with water. This react with water, and as a result, it immediately produces hydroxide ion. Now, the production of this hydroxide ion, due to this oxide ion reaction with the water molecule, make the alkaline solution. As a result, as the oxide ion will be more present in the aqueous solution, the more hydroxide ion will be produced, and as a result, the more strongly alkaline solution will be formed. We know that from sodium, magnesium, aluminium, and silicon, we know that the reaction with oxygen and the product. Now, if sodium oxide, if we add into water, it will dissolve quite easily. If we will add magnesium oxide, it will be the partly soluble. It means that the production of hydroxide ion, oxide ion will be less. So lesser number of hydroxide ion will be produced. So as a result of dissolving magnesium oxide into water will produce weakly alkaline solution. But in case of aluminum oxide, no oxide ion can be produced. That's why the nature of the aluminum oxide with respect to what cannot be alkaline, just only aluminum oxide react with both acid and base. That's why it is termed as amphoteric in nature, because of the reaction with both acids and bases. I hope you have understood all the concepts which I have explained. Please comment, share, like and subscribe the YouTube channel for the further videos of the next chapters. I thank you all.